Hello, let us learn how to draw directions in a cubic unit cell. I will start by just moving right into an example. So in this example, we're supposed to draw a direction with the Miller indices 1, 1, 1 on a cubic crystal. So to do this, I normally start by labeling the X, the Y, and the Z on my given Miller indices. Next, I draw a cube if you are making fun of my drawing skills right now, shame on you. Right, next I then look at the signs of my Miller indices. If everything is positive, as is the case in this example, then I decide that my origin is here, right? And then from here, I then label my X, Y, and Z axis. So let's do that. X, oh, so ugly. Just like my X. Just kidding. And then that is our Z, right? Once I've labeled my X, Y, and Z axis, I then move directions along the X, Y, and Z axis, which are equal to our Miller indices. So I move once in the X, once in the Y, and once in the Z. So that's once in the X direction. This is the Y direction, so then it's once in the Y direction. This is the Z direction, so that means Z direction. We repeat that. So I move once in the X direction, and then Y stop. I move once in the Y direction, and then Y stop. I move once in the Z direction. Right, and then wherever I end up, I then draw dots just to indicate that. So let us do that. Dots to indicate that. And then from there, I then draw an arrow from my chosen origin to the dot. Right, so let's do that. Arrow from origin to the dot. And that's my direction. Easy peasy, right? Easy. Let us see what happened here, right? So first of all, I noted my X, Y, and Z on my given Miller indices. Next, I drew a cube. Then I used the signs of my Miller indices to choose my origin and then label my X, Y, and Z axis. Very important, Gesana, to label this because it shows to your lecturer, it indicates to your lecturer where you drew your direction from, right? And then starting from the origin, I moved distances along the X, Y, and Z axis, which are equal to the amounts given in the Miller indices. Remember, we had 1, 1, 1 in our example. And then when my pen stopped, I drew a small dot, right? And then lastly, I drew an arrow from the origin to my dot. Let us try and work on a few other examples to try and cement these steps, right? I'm gonna work on several examples, and then I'll encourage you guys to do these examples with me, maybe starting from example number 3, right? So you can watch for the next example, and then for example number 3, you can then do the examples with me. I'm gonna keep these steps here so that we keep referring to them as we work on our examples. Right, let's move on to the next example. Draw a direction with the Miller indices 1, 1, 0 on a cubic crystal. Right, so step number 1, we note our X, Y, and Z on our given Miller indices. So let's do that. X, Y, and Z. Step number 2, we draw our cube. Right, so let us draw that. Disclaimer, guys, we all know that I'm not an artist, right? I am a metallurgical engineer. I am a material scientist. So thou shalt not judge my drawing skills, okay? Oh, I think that looks better. What do you think, guys? Yes, I think that looks better. Number 3, choose your origin. So then I look at the signs of my Miller indices, and then I notice that everything is positive. So then decide this is my origin, right? I've chosen my origin, and then I label my X, Y, and Z from my chosen origin. So let's do that. This will be my X, my ugly X. This will be my Y. And this will be my Z. Right. Next step is starting from my origin, I move along the X, Y, and Z. Right. So we move once along the X direction, we move once along the Y direction, and 0 along the Z. So this is where we stop. So let's draw our dot there. Little dot here. And then next step, we draw an arrow from the origin to our dot. So from the origin to our dot. So let's do that. Origin to dot. And there we have it. That's our direction. Make sense? Got it? Easy, right? Stuff is easy. Let's take on the next example. I would encourage you guys to pause this video and then work on this example on your own. And then when you're done, you come back and watch me work on the solution, right? So step number 1, note the X. You will see why noting the X, Y, Z becomes important when we start working with the negative signs, right? For now, it might feel like, why are we even doing this? Because this is obvious stuff. We all know this. But it'll become important when you start working on the negative stuff, and you will see this, right? And noting your X, Y, and Z axis, you will see why it becomes important when you start moving your origin around. You will see. Just wait for it. So that's our Z. And then once we've done that, we move directions along the X, Y, Z. So we're only moving in the X direction here, and we're moving once. So that would be from 0, once along the X direction, and this is where we stop, and this is where we put our dot, right? So we put our not so tiny dot. And then from there we draw an arrow from the origin to our dot, right? Arrow to our dot, and this becomes our direction. Did you get it? Did you get it right? I trust you did. This stuff is easy. Come on, right? Let us work on another example. Things start becoming a bit more interesting now. So draw a direction with the Miller indices -1. So this is how we write -1, 1 with a dash on top, not a minus here. It's here. -1, 1, 1 on a cubic crystal, right? Let us follow these steps. Step number 1, we note our X, Y, and Z. Note our X, our Y, our Z. And then number 2, we draw our cube. Step number 2, we draw our cube. Come on. You gotta give it to me. Sis is getting better at this, okay? I'm getting better at this. Number 3, we choose our origin, right? To choose our origin, we look at the signs. Okay, I'm seeing a negative on the x-axis. This means that we need to move our origin along the x-axis. So let us do that. Our origin usually is here, but because we have a negative sign along the x-axis, then we move our origin once, because the negative is a 1. So we move, if we had a -2, then we probably have to move it twice, but that's a bridge we're going to cross when we get to, right? So we shift it once along the x-axis. So from here, the origin, we move it to here. so it's once along the x-axis. So this will be our new origin, right? And then this will be our y will move here, and then our z will move here, and then our x will move here. Remember that we're still keeping with this notation, so wherever you move your origin to, you keep this notation. This is your positive x, y, this remains your positive x still. So wherever you move your origin to, you're still keeping with this notation. So let us try and do that by labeling our new origin here. So this is still our positive x, and then this is still our positive y. Oh, the consequences of my drawing skills are setting in. Right, so, and then this is still our positive z, right? Cool. Let's move on to the next step, and then from there we move distances along the x, y, and z, right? So from the origin we move -1, isn't it? This is positive 1, positive x. So from the origin we move -1 along the x, 1 along the y, and then 1 along the z, and then this is where we end up, right? Let me repeat that. This is our origin. We're moving 1 along the negative x, and then wherever we stop to continue, we move once along the positive y. Wherever we stop, we continue and we move once along the positive z, and then this is where we end up. Let's draw our dot. This is our dot, right? So next step is wherever we draw our dot, we draw an arrow from our origin, which is this. From the origin, we draw an arrow to our dot. So let us do that. Ooh. Okay, that's our arrow. And this is our direction. Make sense? Easy, right? The stuff is easy. Easy peasy. Right, let's work on our next example. Pause the video, do this on your own, work on this on your own, and then come back to watch the solution. I'm going to work on it. Right, so step number 1, note x, y, and z, right? Step number 2, we draw a cube. Oh, such a massive cube, babes. Such a massive cube. Hey boo, girl. Right, and then number 3, choose my origin. Remember why I said you now. I hope you understand now why you need to note your x, y, and z, because noting them will help you understand where to shift your origin. So our negative is on the z. This means we need to shift our origin along the z axis. So our origin would be here. We shift it from here to here somewhere. So this is our new origin. So let's label our axis based on our new origin. This is our x, this is our y, and this is our z, right? And then from there, from our origin, we move once in the positive x, 0 in the y, and once in the negative y, one negative z, sorry, and then this is where we end up. So let us draw our dot here, hibo dot, and then from there we draw an arrow from our origin to our dot. So let's do that. Arrow from origin to our dot, and there we have it. That's our direction. Got it? I hope you got it right. It's starting to make sense, eh? Stuff is easy. Let's move on to the next example. Again, pause, work on it on your own. I won't be doing much talking. I'll just be doing working, because you guys are big girls and boys now. You get this stuff. at this stuff now. And then I choose my origin, negatives x, so I shift it along the axis. So this is my new origin, x, y, z. And then I move -1 the x direction and 0 in the y and 0 in the z. This is where I end up. And then drawing my arrow. Is that what you got, guys? Please tell me that this is what you got. There's a solution. Easy, right? Let's look at the next example. There's another interesting one, right? We're having 2's now. Draw a direction with the Miller indices 2, 1, 2. Right, let's try and follow these steps and see what we get. Step number 1, label your x, y, z. Obviously, now we've kind of seen the importance of doing this labeling thing, right? I hope we have. Step number 2, we'll draw our cube. What do you think we should be getting? Yo, I feel like this is the ugliest cube I've drawn thus far. Hey boo. Okay, this is our cube, guys, and then from there we choose our origin. Right, so everything is positive, so this is our origin, right? And then we label our x, y, and z from this point. Okay, let us do that. Label our x, our ugly x. Hi boo. X boo looking so fine. Why? X's are not good people. Can't be looking fine here. Okay, so and then once we've done that, we then move distances, right? So we move twice in the x direction. If we were to work on this, we'd have to move 1 and 2, and would end up somewhere here. Do you guys agree? And then once in the y direction, probably end up somewhere here. Personally, I do not like moving outside of my unit cell. It gets messy. Okay, it gets messy and it's hard to plot. So to avoid this, when I come across Miller indices that are greater than 1, first step, I find a factor to multiply them with so that every Miller indice becomes either 1 or less than 1. Looking at these values, what do you think that value would be? What do you think that value would be? I think it should be 1/2. If you multiply everything by 1/2, you get 1/2 and 1. Right? Once we have these, then we can continue plotting using our usual way of plotting. So follow the same rules. We've noted our x, y, z, right? And then we multiply to reduce everything by 1 to either 1 or less than 1, and then we've drawn our cube. Everything is positive. This is our origin, and then from there, starting from the origin, we start moving, right? So we have 1 in the x, half in the y, 1 in the z. So let's do that. So we have 1 in the x direction, half in the y direction. Do you guys agree that this is where we'd end up? And then 1 in the z direction. Let me repeat that. 1 in the x, half in the y, 1 in the z. So we'd end up with a point somewhere here. Let's label our dots, right? And then from our origin, we draw an arrow to our dot. Let us do that. Done. That's our direction. Easy, hey? Easy peasy. Let us draw this direction using these big values so that I illustrate to you guys that this stuff works. You will get exactly the same direction. Let me show you. Let me use a smaller cube this side. You will get exactly the same direction. It's just that using the values as they are, I have to erase it. Using the values as these big numbers makes it harder, but it gets it to exactly the same answer. I'll show you what I mean now. So this is our x, our ugly x. This is our y. And this is our z, right? And then we move twice in the x, once in the y, twice in the z. So 1, 2, would land us probably somewhere here, right? And then let me maybe mark that. So 1, 2 would probably end up somewhere here. Do you guys agree with that? And then from here we move once in the y direction, probably end up somewhere here. So let us mark that. Once in the y direction, probably end up somewhere here, right? And then we move twice in the z direction. So let's do that. So 1, 2. From here, twice in the z direction. So 1, 2. Probably end up with a point somewhere here. So let us draw that point here, right? And then from the origin, we'll draw a line and arrow to our dot. Let's do that. From the origin to our dot, draw an arrow. Exactly the same direction. This direction is exactly the same as this direction. It's just that this one was harder to draw because we had to go outside the unit cell. But this one remained inside the unit cell, so it was easier. So reducing your Miller indices does not affect the final answer that you come up with. The final answer is exactly the same as the final answer you would have come with if you had decided to use these ones. It's just that this one is harder, this one is easier. Whichever one you use is up to you. If you decide to use this technique where you remain, which is easier, where you remain within the unit cell, then you know that you need to have an extra step an extra step where you multiply everything, all your indices, such that all your indices are either equal to or less than 1, and then you follow the exact same steps. Got it? Easy. I've given you guys a few examples to work on in your own time. So when you find time, you can work on these examples on your own. We've got some interesting values here, -2s, -1s. Should be interesting to see what you guys come up with. I won't be sharing solutions to these problems. This is just for you to practice and see, test, and be satisfied with your understanding of the work. If you are interested in the solutions are available in my exam pack. If you're interested in that, leave your comments down below, and I will share I'll share details of how to get access to the exam pack. Alright guys, all the best. See you next time. Bye.